Welcome to online classes of Malabar Engineering College. Okay, I am taking on the topic Machine Design 2. Okay, in that comes the topic known as the clutches. Actually, what is meant by clutch? Clutch is a device that is used to engage and disengage while transmitting the power. While we transmit one power to another power through a shaft, there is a clutch to reduce or increase the speed of the shaft. Okay, and here the clutch we are using is the centrifugal clutch, and let's see a problem based on the centrifugal clutches. Okay, the centrifugal clutch consists of 4 shoes. Okay, here in the figure we can see 4 shoes in the centrifugal clutch, each of mass 1.5 kg. Okay, each the clutches, each the shoes has the mass of 1.5 kg is engaged in the position. Okay, these 4 clutches are engaged. 4 shoes are engaged in the clutch. While the inner radius of the drum is 140. The inner radius, this is the drum, and the inner radius of the drum is 140 mm, and the center of gravity of each shoe is 110 mm. From here to center of gravity of the shoe it's 110, and the inner radius of the drum is 140 mm. The coefficient of friction is 0.3. Okay, always the coefficient of friction of any mechanical device, when it comes in a contact, there will be a friction, and it's 0.3. Okay, the preloaded spring is adjusted in such a way that spring force beginning of the engagement is 700 Newton. When the shaft is engaged, the speed at that time is 700 Newton. Okay, the running speed is 1440 rpm, and that time the running speed will be 1440 rpm. And here is the figure, and this is the side view of the centrifugal clutch. Here there we can see one shaft and another shaft, and here the loaded springs, and when one shaft rotates, the spring will centrifugal force, and it will touches the N2 forces, and here the another speed will be rotated in this shaft. In N1 and N2 will be having the varying speeds. And this is the cross-sectional front view, and we can see the drum, and here we can see 4 shoes, and while it rotates, the inner will stick with the outer drum using the centrifugal force. Okay, and first step, let's write the data which is given in the question. First we have N2, the speed is 1440 rpm. Then we have mass is 1.5, and Z is the number of shoes in this, and it's around 4, and RB is the radius, inner radius of the drum, that is 140, and we have RG, that is the rotation of each shoe from inner till here to the shoe, that is equal to 110, and we have the engaging speed, that is engaging like the power, like that. We have it's at the beginning it's 700 Newton, and coefficient of friction mu is 0.3. Okay, and the things which we need to find is the speed at which the engagement begins. At what speed, at what RPM the engagement begins. Okay, first we have to write the equation. P is equal to M into W omega 1 square Rg by 1000, which is given in the data book, and we have the power. P is equal to 700, and M is given 1.5. and omega 1 is the unknown factor. We need to find the omega 1, and then we have Rg. Rg is 110. In this, while substituting, we can get the angular moment omega 1 is equal to 65.13 is omega 1. Radians per second is the omega 1. Then we know the equation of speed, like 2 pi n by 60. Like we have like 2 pi n by 60, and we are arranging and we finding the speed. Omega is equal to 2 pi n by 60, and we are arranging n1 is equal to 60 omega 1 by 2 pi. With this we can get the value of n1. n1 is the speed, that is 621.98 rpm. That's the starting speed. Okay, while engaging, the speed will be 621 rpm. And the next question is power of the transmission of the clutch at 1440. When the clutch, the power transmission is like, we need to the RPM, and the speed RPM is 1440. At that time, what's the power inside the clutch? That we need to calculate. Okay, for that we need to find omega 2. We found omega 1, Like that we need to find omega 2 is equal to n2 by 2 pi n2 by 60, and we can get 150.80 radians per second. Okay, and we need to find mt. Mt is the equation that is given in the data book, which we need to find the power. Okay, the mt is equal to mu into m into rg into rd into z into omega 2 square minus omega 1 square by 1000. Mu is the coefficient of friction which is given in the question, that's 0.3, and small m is the mass is 1.5, and rg is given 110 mm, and rd is given 140 mm, and z is number of shoes 4, and we square like omega 2 we found here square minus omega 1 we found here 65.13, and we find the entire value of mt as 512,784.60 Newton meter. That is the value of mt. Okay, after finding mt we need to find the power. That's why we found mt. Okay, then the power equation will be P is equal to 2 pi n2 mt by 60 into 10 raised to 6. We are doing 10 raised to 6 because we need to convert Newton mm like the power to kilowatt. So we are multiplying this into 10 raised to 6, and we know 2 pi and n2 is given here. From the question we know what is n2 is equal to 14440, 1440 rpm, and mt we found 512,784.60 and divided by 60 into 10 raised to 6, and after substituting we get the value 77.33 kilowatt, and that's the power developed in like n2, like here what is the maximum power developed, and the power transmitted to the shaft like this n2. And here I wind up this class. Thank you.